In this section, we'll be talking about linear functions and slope. So hopefully a lot of this section is a review for you if you're in the college algebra course. So that's the idea. Hopefully this is a refresher just to kind of remind you about slope, types of, linear equations that we could look at, different formats, the concept of intercepts, all this fun stuff. So first of all, just a reminder of what slope is. We'll use this lowercase m to denote slope. So m equals 2 means the slope is 2. As far as graphing, we usually use this rise over run definition. So if we're trying to graph using the intercept and then the slope to create a second point, that's when we'll use that rise over run definition. Slope in general is change in y over change in x, or sometimes you might have seen this delta notation. Change in y, change in x. Pretty often you guys will be using this slope formula. And I just want to point out, I've seen a lot of students write the slope formula as this. So I want to make sure that you guys can see the difference between what I just wrote and what the actual formula is. The one that I wrote, which is incorrect, and I'm about to cross it out, these are exponents. I have y squared minus y to the first power over x squared minus x to the first power. This is totally incorrect. The actual formula has subscripts. So you'll hear me when I'm reading it out. Sometimes I'll say y sub 2, which stands for y subscript 2. So it's a subscript 2, a subscript 1 in this equation, in this formula. So I just want to point that out. I see all the time on tests students writing it with exponents, and it just drives me nuts. So get out of that habit. These are subscripts. So I'm going to erase this so I don't put any bad ideas into your head. Okay, so for number 1, what we're looking at is 2 points, 2, 5, and 0, -3. And we're asking what the slope is. So first of all, we need to calculate the slope, right? And then we'll see what the actual slope tells us once we calculate it. So to calculate the slope, we can use the slope formula. So we know our slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, little subscripts. And let's say we think of this ordered pair as our x sub 1 and our y sub 1. This ordered pair is x sub 2, y sub 2. All right, so plugging these values into our formula, I've got -3 minus 5, y sub 2 minus y sub 1 over -0 minus 2. Sorry about that. Over 0 minus 2. And this gives me -8 divided by -2. A negative divided by a negative gives me 4. So my slope is 4. My slope is positive 4. So a couple of things, we'll kind of redo this. We'll talk a lot about number 1, and then we'll do, 2, 3, and 4 a little bit more quickly. When you guys give me a final answer, when I say what's the slope on a test, in this case, you would give me 4. I don't want you guys to give me 4 over 1. You could use 4 over 1 for rise over run graphing purposes, but that's not simplified. So I want you guys to always give me a fully simplified answer. So if the slope is 2 over 4, you guys are going to tell me 1/2 because that's fully simplified. If the slope is 4 over 1, you're going to simplify it to a 4 and all that good stuff. Okay, I also want to show you guys that the order that the points appear in doesn't matter. So let's say that instead I called 0, -3 my x sub 1 and my y sub 1, and then 2, 5 is x sub 2, y sub 2. Okay, so let's go ahead and calculate the slope using this new order and see what we come up with. So I'll do this up here. So in this case, m equals 5 minus -3 over 2 minus 0. Up in the numerator, this is really 5 plus 3. We have that double negative. Minus -3 is plus 3. 2 minus 0 is 2. So we have 8 over 2. And notice that we still get 4. So we got positive 4 the first time, we got positive 4 the second time. It doesn't matter which order you put your points in, what you call your 1s and what you call your 2s. What does matter is make sure that vertically you're keeping your points lined up. So here, 2, 5 is a point, 5 and 2 are stacked vertically. Over here, 5 and 2 are stacked vertically, right? So we have 0, -3, 0, -3 are stacked vertically, 0, -3 are stacked vertically. So make sure that you keep that vertical alignment intact. That's very much important. But if you put your 1s first and your 2s second, that actually doesn't matter. So the order of the points doesn't matter. Also, make sure that you put your y's on top and your x's down in the denominator. That certainly matters. But as far as the order of the points that you write them in, that doesn't matter. Okay, all that to say, our slope is +4, so what does that tell us? If I look at this line that we have on our graph, so here's our line that passes through 0, -3, and 2, 5. I can see that this is a positively sloped line, so I can see that this line has a positive slope. What I mean by that is, as I'm reading the graph from left to right, so I'm always reading the graph from left to right, okay? So as I'm moving from left to right, okay, go in that direction. I'm going to erase that. As I'm moving from left to right, I'm also increasing. Okay, so I'm moving from left to right. My pen is also going up. So my function is increasing as I go from left to right. And we'll always see this with a positive slope line. The slope of +4 is pretty steep. So it's a pretty steep positive slope. If my slope were instead +1/4, I'd have a much flatter line, so something like this, okay? So the steeper your slope is, the bigger the positive number is for your slope. Okay, let's take a look at number 2. So we've got -3, 4, and 3, 0. Plugging this into my slope formula. 0 - 4, subtracting my y values. Over 3 minus -3. So up top, I have -4. In the denominator, 3 minus -3 is 3 plus 3. So -4 over 6. I'm going to simplify that to -2/3. So that's my slope, -2/3, fully simplified. And if you guys tell me the slope is -2/3, that's fine. If you tell me that the slope is -2/3, I'm okay with that. I don't want you guys to tell me that the slope is 2/-3. So I want you guys to avoid that. We don't like negative numbers in our denominators. Okay, so this would be fine by me. -3 in the denominator wouldn't be okay. All right, so our slope is -2/3. Reading our graph from left to right, as I move my pen from left to right, I can see I'm also heading down. Okay, so for a negatively sloped line, which this is, I have a negative slope, -2/3. I can see that the line is falling, meaning it's decreasing. Both of these are functions. Both of these are straight lines that would pass the vertical line test, so these are both functions. Okay, let's move forward to number 3. So the slope between -2,5 and 4,5, using my slope formula, 5 minus 5 over 4 minus -2 gives me 0 over 4 plus 2, which is 0 over 6. And that simplifies to 0. And if you're not sure, if you have a brain fart, use your calculator. 0 divided by 6 gives me 0. So this line has a slope equal to 0. So a slope equal to 0 will always give me a horizontal line. A horizontal line always has a slope equal to 0. A slope equal to 0 always corresponds to a horizontal line. So those two are always a pair. These always go together. Okay. And this is a function. This would pass the vertical line test, right? So this passes the vertical line test. And by the way, if I wanted to write an equation of this line, any horizontal line is going to have an equation in the form y equals some number. So y equals 2, y equals -5, y equals 7, y equals pi, right? So if I wanted to write an equation of this line, it would be y equals, and then look at my two y coordinates. Y equals 5 in the first point, y equals 5 in the second point. That's because for this equation, y always equals 5. So for a horizontal line, the equation will always be y equals a number, and it'll always just be the y coordinate that appears in your coordinates, the y value that appears in your coordinates. So any point that falls on this line, 0, 5, 1, 5, 1.5, 5, any of these ordered pairs is going to have a 5 for the y value, so the equation is y equals 5. And by the way, if I wanted to rewrite that equation in function notation, remember that y equals f of x, so I could rewrite this as f of x equals 5. If I asked you guys to graph f of x equals 5, you would give me that horizontal line y equals 5. Okay, let's move over to number 4. If I'm calculating the slope, this would be -2 minus -3 over -1 minus -1. Lots of negatives, so keep an eye on those. Got 2 sets of double negatives here. So in my numerator, -2 plus 3, denominator -1 plus 1. -2 plus 3 is +1. And then in my denominator, -1 plus 1 is 0. And if you have a brain fart, you forget what this is, try it in your calculator. Oop, and of course my calculator is freezing. But if you guys try this in your calculator, 1 divided by 0, you're going to get some sort of an error message. So that's because this slope is undefined. This slope is undefined. So for a vertical line, you will always have an undefined slope. If your slope is undefined, you will always have a vertical line. So these guys always go together. And this would not be a function. This would not pass the vertical line test, right? So if I draw a vertical line here, I'm obviously intersecting my graph at multiple points. So this is not the graph of a function. And when you guys are telling me what this slope is, I don't want you guys to say no slope. I'm not really sure what that means. I see that a lot on test day. Don't put that. I don't want you guys to put no solution. Again, not really appropriate here. And along those lines, don't put that because that means no solution. That's not appropriate here. I literally want you to write the word undefined, all right? That's the only correct answer. Okay, so undefined slope, vertical line. If I were to ask you guys what the equation is, okay, so what's the equation for this line? The equation for a vertical line is always going to be in the form x equals some number. So in this case, if we look at our two x values, we get x equals -1. Can I write this equation again in function notation like I did before? So could I write f of x equals -1? The answer is no. F of x equals -1 would be a horizontal line at y equals -1. I can't write this in function notation because this is not a function. So the only way to write this is x equals -1.